Welcome to CiuLabs, an initiative of Cambridge Intercontinental University. Imagine you're browsing the web and you see an interesting link. You click it, eager to learn more. But have you ever wondered what happens after you click? It's the start of an amazing journey for information. Your click tells the web browser to request information. This request is a message, but not in a language you or I would understand. It's in a special computer language called HTTP, which stands for Hypertext Transfer Protocol. Think of it as a set of rules for how computers share information online. The message, called an HTTP request, contains the address of the web page you want to see. It's like putting an address on a postcard before you send it. The journey has begun. The request is ready to be sent, but first it needs directions. We use website names like google.com because they're easy to remember. But computers need numbers to find each other online. These numbers are called IP addresses, like a digital street address for websites. That's where DNS comes in, the domain name system. Think of it as a giant phone book for the internet. When you request a website, your computer asks a DNS server to look up the website's IP address. Once the IP address is found, your request now has the directions it needs. It knows exactly where to go. But before it can deliver its message, it needs to establish a connection. Imagine two people using walkie-talkies. Before they can talk, they need to make sure the other person is listening. Computers do the same thing using a process called a TCP handshake. TCP stands for Transmission Control Protocol. It's like a set of rules for a reliable conversation between computers. The handshake ensures that both computers are ready to send and receive data. During the handshake, the sending computer says, "Hello, are you there?" The receiving computer responds, "Yes, I'm ready." Now, a secure connection is established, like a dedicated phone line between the two computers. With the connection established, it's time to prepare the data for its journey. The HTTP request is packaged into a special container called a packet. Think of a packet like an envelope. Inside the envelope is your message, but the envelope also has important delivery information on the outside. The packet is wrapped in several layers, each with a specific purpose. Ethernet header. This layer tells your local network where to send the packet first. It's like putting your friend's address on the envelope. IP header. This layer provides the source and destination IP addresses, ensuring the packet reaches the correct website. It's like adding the country and postal code. TCP header. This layer ensures all the data arrives in the correct order and without any errors. It's like numbering the pages in a document. Section 5. Riding the data highway through routers and servers. The packet is now ready to travel across the internet, a vast network of interconnected cables and computers. Think of the internet as a system of highways. The packet travels from your computer to your router, which is like an on-ramp to the information superhighway. Along the way, the packet passes through other routers and servers, each directing it closer to its destination. It's like making connecting flights to reach a far-off country. Each router reads the IP address on the packet and decides the best route to forward it, like a GPS guiding the way. Section 6. Arrival and unpacking. Reaching the destination server. Finally, the packet arrives at the destination server, the computer that hosts the website you requested. The server receives the packet and starts to unpack it, removing each layer like opening a carefully wrapped gift. First, the Ethernet header is removed. then the IP header, and finally the TCP header. This process ensures the data arrives intact and in the right order. Now, the server can finally read the HTTP request and understand what information you're looking for. Section 7. The return trip. Receiving the web page. The server processes your request and prepares a response which contains the website data you requested. This data could be text, images, videos, or anything else that makes up the web page. This response data is packaged into new packets and sent back to your computer following the same route in reverse. The packets travel from the server through various routers until they reach your home network and finally arrive back at your computer. Section 8. Displaying the page, the journey's end. Your computer receives the response packets and starts to unpack them, just like the server did before. The browser assembles the data from the packets and displays the web page on your screen. Images are loaded, text is formatted, and videos are ready to play. And that's it. The journey is complete. From a simple click to a complex exchange of data, you've witnessed the magic of the internet in action.